Okay, so let's go ahead and talk a little bit about chapter 6. Last week, you guys started on user-defined methods, and this week you're also continuing to look at user-defined methods. There was a total of 21 or 22 PAs for the entire set, so we broke it up into 2 weeks. This week we're going to continue to look at user-defined methods, and today we're going to basically in our lecture just kind of briefly go over what they are, how you use them, and how you're going to be using them on your project, which I want to go over with real quick. So you're going to complete the Chapter 6 PAs. I think there's one CA and there's one lab. You'll have a Chapter 6 quiz this week, which will go over what you've learned from last week and the rest of this week. And then the project, which will be due on March 9th. That will be Wednesday, a week from tomorrow. Okay? There is no discussion forum this week. All right, so let's look at the Project 2 scenario. You're basically going to create a class, and this class is going to be called Player Health. It's going to include 3 overloaded methods, and these method names are going to be calculate hit points. Basically, this is going to be a simple text-based online fantasy computer game. Okay? It's going to be the most basic game you've ever played, in fact. The 3 overloaded methods, these are going to determine the the impact cost on the overall health of an individual, whether they're struck by a sword, a spell, or by hand. And so you're going to be writing, using the scanner interface, the scanner method, capturing the type of action that's going to occur against them. Okay? Now these are the code requirements. Each parameter passed in must be of type integer. Okay? Type integer. So the value displayed that's returned from the calculation has to be a decimal number. This could be a double or a float. Okay? A double or a float. So the first method says calculate hit points, and this is a very simple method signature. It's going to return double. It accepts one parameter called hand strike. It represents the hit point cost of a type of hand strike. Hand strikes will have one parameter of the point level of the hand strike and will be multiplied by 2% damage against the overall health of the individual. This means that a hand strike is going to be added to the 2% total life damage of that person. So think about the sample algorithm here. Here's the total health, the hand strike, whatever that amount is, whether it's 10, 20, 1, 2, right? It's plus 0.02 times the total health. Okay? And then you're subtracting that from the total health and assigning it back to the value total health. That will be the algorithm used in that method. Now, when you're using the second overloaded calculate hit points method, it's going to be hand strike and sword strike. They receive 2 parameters in this overloaded method, and it represents the hit point cost of one sword strike plus the hand strike. So parameter 1 is the level of the hand. Okay, so your hand strike could be 1, 2, 3, 4, 5, whatever it is, because it's up to you. It's up to your creativity. And then the level of the sword. Austin, would you mind closing that door for us? Okay. Again, this is the sample algorithm that you would use for it. Okay. The hand strike plus the sword strike plus 0.02 times total health minus total health. Okay? Then you get to the third overloaded method. Now, the reason why we're focusing on overloaded methods for this project is because that's what hopefully will have learned by the end of this week, okay, in creating methods. So you're going to create this method is going to be, again, calculate hit points. It takes a parameter for hand strike. It takes a parameter for a spell type and the spell power. Okay, those are the three parameters. And it represents the hit cost of your hand and whatever the spell strike is together. So parameter 1 is the level of the hand, parameter 2 is the type of spell, parameter 3 is the whatever you want to call it, okay? So let me give you some examples here. In this example, this is the sample algorithm again you're going to use, hand strike plus spell type plus spell power. Very basic, right? You should be able to do this. If you have the initial health points at 200 when the game begins, you're going to be using that 200 then to calculate for each of the algorithms as you move down through the player health class. Okay? So the first method, called the total health, is smaller, and it'll get smaller and smaller and smaller as you call each of those overloaded methods. Okay? By the end of the third method, you're trying to see what it'll take to deplete the total health of the individual. Okay? All right, so that's the method you're going to write. You're going to put that in your main method and call those three overloaded methods. Make sure you don't use magic numbers. What I mean by magic number is not necessarily something referencing in game lore. I'm talking about magic numbers where you put 0.02, but you don't tell us what 0.02 is, right? So instead of that, we create a variable, a constant at the top, right? And we say final double life cost is 0.02, right? We define it. And then when it gets to the items and the names of your spells, your swords, your hand strikes, whatever, create a meaningful name that represents that type of hand strike or sword or whatever, okay? This is a very basic project, but this should stress the skills you've learned so far in using loops, in using arrays, constants, and how to use methods, overloaded methods. Okay? Again, that is due not tomorrow, but next Wednesday. Okay? Any questions? When you turn in your code, make sure you only turn in just the one Java class. Someone in here, they turned in a PDF and they didn't actually turn in the code. I sent a message back saying, please turn in your class, the Java class. I don't remember who it was, but please make sure you're reviewing the project one, because some of you, I'm still waiting on the code to be sent back to me. Okay. Your source code at the top, you're going to put in comment your name, the date, project 2 at the top of the code. Okay? All right. Let's go ahead and look at the participation activities this week. We're going to be picking up at 6:11, which is variable and method definitions, a method name overloading, parameter error checking, using the scanner methods, and why we only want to use it one time within a class, and we just use that one instance of it. There's some discussion of perfect sized arrays, oversized arrays, and some other things that deal with how primitives are stored. Okay? Let's go ahead and take a look at some slides here and talk through some of this in general from what you all should have been learning so far from last week. All right, so methods. Methods, these are what really makes your programs powerful. Methods are a way of scoping out a chunk of code so that you can use it again and again and again and again without having to repeat yourself. When I'm at home and some of my kids would ask me questions and I repeat myself, right? it gets a little tiring after a while, right? It's the same way when you're writing code. If you have to keep repeating the same things over and over and over and over and over and over and over again, that makes your code not very expressive. It's very tedious and time consuming. So what you want to do instead is say, okay, here is a block of code that's represented by a label, and that label is what we call our method. And so we call that method, and when we do, it repeats a static block of code. Now, methods are kind of special because with methods, they can accept parameters and they can return values. They can accept arguments and they can return values. And that's important for making your code less redundant and repeatable and more user-friendly. I want to recommend your course textbook is not really going to say this, but you really want to make sure that your methods only do one thing. You don't want a method doing 5 or 6 things. You want your method to be specialized. You want it to only focus on one thing. That will make your code very, very succinct, right? So for example, if I have the method sum, well, what does the method sum do? It does one thing. It doesn't multiply, it doesn't divide, it doesn't subtract. It might subtract, right? But when I say sum, it's going to give me just one type of operation. If I had a method, for example, called add, the method add would only focus on one thing. So when you write your methods, make sure that they are succinct. They're kind of atomized. They do one thing and they do one thing really well. And that's important for repeatability, for testability, for making sure that your code operates in the way you think it should. So a method name it's just a list, it's a label with a list of instructions. So for example, we have here public static double calc pizza area. The method name itself specifies what we're actually doing. We're calculating the pizza area. So your method call, when you call that method, you're invoking it. You're saying, okay, I want you to go do this thing that I have created for you to do, right? It's an invocation. And of course, everything inside the method, inside the curly brackets, that's called a block, okay? All right, so when we look at methods, we see, for example, in this class, we have public class pizza area. It's the name of the class, and it has 2 methods in it. It has a calc pizza area, and it has, of course, the static main void method. Calc pizza area, it does one thing, right? It calculates the pizza area. Now, your methods, both of these methods, calc pizza area and main, you're going to find in the Zybooks textbook they're both public and they're both static. Public is the access modifier. We're going to get into more access modifiers next week when we look at classes, but access modifiers basically say who has the right to access that method. So if you're inside of a class, you may call a method public. You may call a method private, or you may call it protected. And each of those have important public access. They have important access accessibility for other users outside of the class. Again, we're going to get into that next week, but in general, if something is private outside of the class, they can't see the private method. Private methods can only be seen within the class itself. If it's public, it can be seen by anyone outside the class. If it's protected, it can only be seen by those within a special collection of packages, or it's called package level visibility. Okay? Public indicates that the method may be called by any class in the program. And of course, static indicates that the method only uses values that are passed to the method. we're going to be talking more about static later, but if your class has static methods, that class does not have to be instantiated in order to call that static method. You may not understand this yet because a lot of this you're not going to get into until next week or the week after. But for right now, I just want you to take me at my word at this. If you have a static method, just know that only if you have a static method, anything can call it without being instantiated. Okay? Instantiated is one of those words that we're going to get into more, but it's important. If your class methods are not static, the class itself has to be instantiated to call those methods. Okay? And I'll demonstrate this in a little bit here in code. Again, you don't have to understand it just yet, but just kind of keep these as a rule of thumb as you go forward. All right, let's go ahead and open up some code and run some examples here. If you will, go ahead and open up an IntelliJ with me so we can code together. We're going to do a new project. Once you have your new project, select your Java version. If you're using anything 1.8 and above, I'm using Corretto 17. Click Next. We'll leave this blank. Click Next. And I'm just going to call this Chapter 6 Examples. Once you get this open, go ahead and expand the tree there on the left. Go down to Source. And we're going to create a new class. And we'll call this our main class. Hit Enter a couple of times inside. And there's in IntelliJ, remember, we have some shortcuts, so we can type PSVM and tab, and you get all of that wonderful code for free. PSVM and then hit tab. All right, and let's go ahead and create a couple of system out print lines. You can type SOUT and hit tab, and it gives you the system out print line. Hi, let's see. Hello. What is your name? Below that, we'll use a scanner. And what I'm doing with the scanner class is I'm instantiating an object. Now you may hear that definition, instantiating, and that's important. The scanner has a constructor that only accepts a system.in, so we're going to do that. And I'm asking the question here in my code, hello, what is your name? And so I'm going to type scanner, next line, going to assign this to a string called name. And we're going to do another system out print line. Welcome plus name. Okay, very basic stuff. This is stuff that we've done over and over and over again kind of in this class in many different variations. If we go ahead and click run the main method. Hello, what is your name? I'll type in Michael, hit enter, and it says welcome Michael, right? But let's say now I want to make this more interesting, where I could accept my name and then somebody else's name and somebody else's name and somebody else's name and so forth. Well, what are some things that I could do? This is the perfect opportunity for creating a method. Now, in this instance, I'm going to create a public static method. And the reason I'm going to do that is because the main method up here is static. And if I want to call that method, it either needs to be static or it needs to be instantiated. The class itself needs to be instantiated. So for right now, your first example is I'm going to show you, I'm going to create a method that's static. I'm going to use public static void, and I'm going to say the name of this method is going to be greeting. And I want my method to accept a parameter of scanner, just like that. Now, I'm going to take my code up here, cut it, paste it down here. I'm going to take out the scanner right there because I don't need it, because I'm actually saying it's going to be provided in the method. Okay. And then up here now, I'm going to utilize that method that I just created. So we'll type greeting, and I'm going to put my scanner out here. Scanner equals new scanner system.in. Going to supply it my variable scanner. Now, what I've simply done is I've made this code now repeatable. I can repeat it again and again and again and again if I want to. So for example, I'll type greeting again, pass in scanner, and save it. All right, so let's go ahead and run our main method. Hello, what is your name? Michael. Welcome, Michael. Hello, what is your name? Austin. Hello, Austin. And then it exits. Let's say, though, I want this to be a little bit more expressive. Let's say that I want it to occur so many times. How would I do that? How would I get this method call to occur, say maybe 10 times? Yeah. Do a for loop. So for Zachary, give me the parameters. What should I type? I equals what? 0. Okay, and then okay, how many times do you want it to go? 6 times. Okay. And then what else do I type? Okay. All right, so now I have my greeting set to run 6 times. So we'll save it, we'll run it, and you know what? To make sure that we're representing how many times it's ran, let's change our method and add a number here. We'll say int trip. So up here, I'll pass in the argument for that int, and I'll just supply it in I. Now, system out print line. We'll say I oops, not I, what is it? Trip. Okay. So let's come up here and run our code. Hello, what is your name? Let's see, K. Welcome, K. What is your name? Let's say Austin. Okay, Austin. Now it's ran 1 times. What is your name? Let's see. I need some more names. Someone nominate a name. John. Hello, John. How about Zachary? Hello, Zachary, right? We could do this all day, right? Isabel. Clayton. Right? Now, we know it ran 6 times. It says 5 times ran, but we also know that the beginning of the increment was at 0, right? So we could adjust that. We could say I equals 1. I is less than or equal to 6. And then, of course, when it ran, it would actually increment and match up to the number of times, right? All right, so that is setting up our scanner, right? And this basically then makes it repeatable. Okay, let's go back to our not that and not that. There we go. So the parameter is what we define. We define the parameter, and when we utilize that parameter, it's called an argument. So, for example, I created my method to have a parameter of type scanner, but when I populated it, I gave it the argument of an instantiated scanner object, right? A little bit of semantics, but it's important when we talk about that. Okay, method statements, they can call other methods. For example, you could have a method that does one particular thing and captures that data. And say you want it to happen X amount of times. Now, if we go back to our example here, we see exactly that. We have the greeting method, and it's called by the main method. Okay? Hey, Mike, why don't you sit up for us? Thank you. So you have the main method, you have the greeting method, and we can see that we can call a method can call another method inside of a method, right? All right, so let's talk about for reasons for defining your methods. Back in project 1, I asked you to create a class called the NMC Bookstore Credit Fund, right? Or something like that. And there were some times that you had to input the same message over and over and over and over again, right? Now, if we were to think about it, that class would be a great example of how you could implement your method. So, Austin, when you wrote that class, what was one of the questions that you found yourself repeating? Yeah. Yeah. So you could actually, if you think about it, you could take that question and embed it inside of a method, couldn't you? And then you would output that maybe in a loop. And in that loop, then you could output the data on each iteration of the loop and write it to like an array, right? So those are examples, reasons, a good reason for defining a method. It allows you also to break down harder concepts. So I said this a minute ago, that when you define your method really should only do one thing. And it should do only that one thing well. The reason for that is when you have really hard algorithms that you have to write, you don't want to try to write this huge algorithm inside of your code when you know that certain parts are going to have to be repeated. So you try to think about, okay, how can I break this down into manageable chunks, each part, so that each part has a distinct purpose, it does a distinct thing, it produces a distinct value. And then you can join those together. That's what we find when you look at the math class, for example. When you look at the math class, we see that there are a number of distinct methods, and they all do just one thing. And they do it really well. But at the same time, all of those small mathematical operations are often joined. If you remember your geometry, your algebra, or your calculus class, sometimes when you want to get, some of these complex calculations, they're all using theorems from earlier points. And you just trust them because you say, okay, yeah, that is distinct. I can trust that particular theorem, that it produces this output, this value. It's the same way with Java. When I was working for the Department of the Army, we had this project where we had to take a PDF and we had to digitally create it on the fly with the values. So the user would sit down at a desk and type in some information, and it would take that data and it would create what was called a officer evaluation record. And that officer evaluation record is a big deal in the Army. They use that for promotions and everything else. And so when I was having to create the programs that were actually creating these PDFs, all of us developers were really focused on doing one thing. We all focused on our one area to produce that would produce a well-tested set of data, and then it all came together to produce the final outset. It's the same thing that we see here. The same concept that we're talking about. Okay. We want our programs to be modular, meaning that maybe down the road you may say to yourself, you know what, I wrote this method already. I can reference this from another class that I wrote previously because my method is modular. It's repeatable, right? And of course, this is the big idea. You want to avoid writing redundant code. If you find yourself repeating yourself, that's a good place to put a method. Encapsulate it. Encapsulate that logic so that you don't repeat it. Now, another reason for that is if you find yourself repeating yourself over and over and over and over and over again, and you have to go back and change one value that's repeated in all of those places, well, that's time consuming. But more than that, it's also a huge opportunity for you to introduce bugs into your code that you don't want in your code. You want to keep it very, very simple. All right, so methods using branching. Let's go back to our example over here. We have a greeting class and we have a scanner. Let's say, though, that in my scanner, I'm going to have another value I'm going to include in this. And this value is actually, let's do it down here. Let's say system out print line. Let's not do that. Let's say, do you want to quit? Okay. And I'm going to call my scanner. And I'm going to say next line dot char at 0. And this is going to be char y, right? And up here, instead of returning void now, I want my method to return an int. And we're going to ask a question here. If let's say int return value. If the return value is equal to -1, break. Okay. And down here, we're going to say if y is equal to let's do it this way. That's too prone to error. We'll say y equals, ignore case, y return -1. Else, oops, else return 0. All right, you all understand what I've done so far? So what I've did is actually put a little branch logic in here, and I've wrote this code that if y is, if the person says, yes, I want to exit, then we're going to return -0. And up here, inside the for loop, I take the return value and I check, does the return value equal -1, right? And if it does, then we're going to break out of the loop. All right, so let's go ahead and try it real quick. This is just a simple example of including branching logic inside of your methods. So Michael, do you want to continue? No. Okay. Let's see. Kaylani, do you want to continue? Yes. You want to quit? Yes. And of course it exited out early, right? So you can also do different branching logic inside of your methods. You can use methods with loops, like exactly what we've been doing so far, right? Another good practice is to write unit tests. Now, there are a number of actually good libraries, APIs, that you'll find professional development shops use. Some of these are like JUnit tests. And JUnit is an API that's written that incorporates all of what's being talked about here, where you'll have a class and then you'll write a separate test class to test your class. Testing is essential. It's essential in all types of software development. Typically, it's your code won't go to production unless you have good unit tests that are written. And unit testing, as you can see here, and you're going to find this in your course textbook, it's the process of individually testing a small unit of code to make sure that it's producing what it's supposed to produce. So if you have a set of code that's supposed to do addition, then you want to do a sample test. Write a test case that makes sure that it actually does addition. If you have a set of code that's supposed to test for certain values and produce certain outcomes, maybe it's a piece of code that gives you the day of a week when you enter a number, then those are all very distinct testable pieces of code. So typically it's conducted, what they talk about here is a test bench and a test harness, and then of course the test values are called test vectors. All right. We talked about the assert operator back, I think, in week 2 or week 3. Assert is an actual operator, just like the plus operator. Assert is used for specifically this scenario. So you would write assert, this is the keyword, then whatever the expression is, the expression has to resolve to true or false, And if it resolves to false, then you have to have the message that relates to that message. Okay? Message that relates to the error that you're identifying. So here's your example. If you have a method, name hour, minute to minute, it takes in these parameters, the origin hours and the origin minutes. You would write assert. Notice that this whole piece here is wrapped in a parenthesis because it's trying to evaluate. It takes the parameters it operates on, and hour to minute returns an int. And so they're saying if it's 0 and 0, that it should equal 0. And if it doesn't, then the assertion, you print out the assertion message. All right, so let's run a quick test with that for a moment. Let's say down here at the bottom, actually let's do this right here. Let's have the assert. I have my method, and I know my method returns an int. Okay? So I'm going to assert the greeting passed in with my scanner and a trip value of 1, and the error message. Okay? Now, what I need to do here is I need to assert that it's either going to be that the yes question is going to work, right? So I'm going to say equals -1. And for simplicity, I'm just going to comment out the rest of that code there. If I run this, it's asking me the question, so I'm going to type in oh, it already exited, didn't it? Let's change it up a little bit.
So, you can call the method even if it's below your main method? Like you can call it before it's...
Yeah, that's what we've been doing. Yeah. Let's change this up because I think the invocation here is not a good example. Let's do public static int add int a int b, and this is going to be return a plus b. Okay, so we're going to take out some of that, and we're going to say add, and 1 and 1 should equal 2. Okay, and if we run it, it's going to assert fine because 1 and 1 doesn't error out. But let's say that for some reason that my code did error out. Let's say that 1 and 1, let's say for some reason there was a problem in my code that I had put in a minus instead of a plus. So now when I do 1 plus 1 equals 2, it should assert and give the error message, right? So let's run it. Is it really going to do that to me? Well, let's put the debugger on it and see what's happening, because clearly it's not doing what I think it's supposed to be doing.
Was that what that red dot is?
Yep. Okay, so there's the scanner. The object is instantiated. Go down to the assert. And it already exited. All right. I'm going to come back to you on this one because I think my IntelliJ is intercepting it. All right, let's go on. I'll come back and give you all the correct one on that later. The name of your variable methods. Okay, we talked about this earlier, that the values earlier on in week 3, we looked at variable values, right? The scope. So if we're looking at, say, our code here, pull this out so we can look at it together. I create a variable down here inside this method called string, that's a string y that holds that variable, right, that value. The scope of this variable y is only known inside the Java program, inside the greeting method. So it's not globalized. Whereas up here I have the scanner method, and this scanner, as you can see, is passed in by reference to the method greeting. Do you guys see that? Okay. So when the scanner object itself, now the reference to this instantiated object is passed in, it's part of the scope in this project. However, the y, this variable right here, its scope in memory dies once it gets to the last curly bracket. Okay. Let me break this down a little bit further for you. The scope of a variable up here, int I, let's see, int number equals 0. Up here, this variable is global. And so it's globally accessible by the main method and the greeting method. Okay. Now there are some caveats here, because the main method and the greeting method are both static. And so if I try to access num, I'm going to get an error message. It's going to tell me that it's a non-static number. And the only way I can access this value then is by instantiating the main class itself. I would have to say main now I can access the num, because it's at the global level. Now, if I really want to access it, I'd have to do it like this. That's not a statement, but I could take this value now and I could assign it var x equals that value. Okay, but I can't access num itself because it's not static unless I instantiate the class. Now the variable itself, this is a global scoped variable, and as long as I can instantiate it by each of these methods, I can access it. And that variable itself is global. It's across the entire class. However, the main method itself, it cannot access, from down in the greeting class. It can't access the the y variable, because y is scoped only to this method. Okay, so that variable cannot be accessed outside of it. If I need to get to that variable somehow, then I have to return it from the method. And right now, the only value that's returned from the method is this -1 or 0. Okay, so that's the scoping of those values. Now, I just introduced you something here with the main method. Let's say that my greeting is not static. If public int greeting is not static, you'll notice here that it's already complaining. It says, well, I can't access it because it's not static. And so then the only way for me to access it is to use the instantiated parent class. And by doing that, by accessing this parent class that I instantiated, I created an object in memory. Remember that. Anytime I say equals new, whatever the class name is, I've now created a place in memory that has that object.
So when you instantiate your class, does it have to be in the main method, or can it just be like...
It does.
Okay.
It does have to be in the main method. It does. Now, this gets to a whole lot of other interesting things that you can do with your classes. For example, we could go ahead and create public string name, and down here in the greeting we could just say name. And the reason why I can access name here and it not complain is because this is not static. Does that make sense? As soon as I make this class, this method static, then accessing the member variables, I have to instantiate. So again, if this is let me put this in here, public static, now I can't do that. I have to actually, inside of the greeting method, I would have to do something like this. Main im.
You have to do it again.
I would have to do it again.
So you can just do .m for that?
No, because this is now a static method.
Okay.
Right? Now there's other ways to pass in that value. I could do something like this. I could say main. Now up here on my method, of course, I would have to pass in my instantiated value of the class. I don't recommend doing that because keep in mind I've created a main method here in object, and now as I iterate across this, I am creating 6 distinct references in memory to the main class object that's been instantiated. So I don't recommend doing it that way, but that's really the only way you could access then those values. All right, any questions so far? No? Okay, let's go back to our class here. And let's talk about method overloading. And to do that, I want to go ahead and create a new class here. And we're going to call this class Player Health. And in my Player Health class, if you guys are following along what I'm doing, you might be wondering, oh, I maybe need to type along with him here to capture some of this, because this is your project code. So public static void main method, I'm going to create a public double, and if we were to look at the method name, we need a method called what? Calculate hit points. Okay, and the first one is going to be our hand strike. Now I'm just going to stub this out for right now. And I'm going to create another one, public double calculate hit points. This is int hand strike and int sword strike. Return double. We'll do one more. Public double calculate hit points, int hand strike, int spell type, int spell power. And I forgot how to type. There we go. Return double. Now, with what I've typed so far, I've actually stubbed out the basics of our project code, right? And I have 3 methods, and they all have the same name. And this is called method overloading.
So it's just like what you do when you get more than one input.
Yeah. The catch here with method overloading is that your return value always must be the same. You can't have a different return value. So if I went in here and did that, that's not method overloading. Okay. Okay, so you have your method overloading. Let's take our project code though, and let's start with some basics. So we come in here, and we know that we need the total health points to start at 200. So let's start up here and create a an int total health point of 200, and we need a life cost. So this is going to be a final double life cost and that value is going to be 0.02, right? Okay. Let's take a look at some of our algorithms here. Just going to copy that and paste that in. So we know the hand strike. We don't know is the 0.2, right? But we have that already up top. So we're going to replace that with the life cost. And going to I think we need to make this a double. Okay. Now let's create some different types of hand strikes. I'm going to have a public, static, final, int. Does anyone here take martial arts? Anyone do boxing? Anyone watch MMA? Okay, someone give me a funky name for a hand strike then. A jab? All right, so how much do we want our jab to be? What's that? 5. All right. Let's create another type of hand strike. What do you want to call it?
Super punch.
Super punch. Whoops, that's supper punch. I mean, there's nothing wrong with a supper punch. All right, so a supper punch. Super punch. How much do you want the super punch to be? 20.
6.
What's that?
6.
You want it to be 6?
Yeah.
Okay. All right. One more type of punch. One more type. What do you guys want to call it?
Punch.
Just a punch? Okay.
7.
7?
Yeah.
You want to call it a fruit punch? No? All right. All right, so we have also sword strikes, right? So let's see. What type of sword is this? You guys have a favorite sword?
Spaghetti sword.
Spaghetti sword.
Yeah.
Are you doing this because you can't spell spaghetti?
No, I just lying.
Let's see here. Spaghetti.
There's an H in there, I'm pretty sure. After the G.
There you go. All right, spaghetti sword. Now, how much is a spaghetti sword?
17.
17.
Yeah.
All right, let's do another sword. What type of sword, guys? How about a broadsword? What do y'all want the broadsword to be?
3.
Okay. And one more type of sword. Someone give me a sword. Katana. Can you spell it for me? Like that? Okay. And how much is the katana? 10? All right. And now we're going to get to our different types of spells. Okay. So just to keep these all, make it easier, we'll say spell and then
Taco seasoning.
taco seasoning spell.
Yeah.
All right. You know this is supposed to kill, right?
It will.
Okay. How much is the taco seasoning spell?
25.
25. All right. And let's do another spell. How about lightning?
Sure.
Okay. What do you think the lightning spell should be?
6 sounds about right.
6? All right. How about this one? How about we do a tornado spell? Tornado. How much is a tornado spell?
Gotta be 5.
2? Okay. And then the last one, according to our is the spell power, and we don't necessarily have to come up with a number, designated number for that, but we could say it's, you know, any number between 1 and 10, maybe. I don't know. Okay.
So when we calculate the damage that's done by the things, we have to use that algorithm that's the total health plus the thing plus the, like that one?
Yep.
Okay.
So we'll come in here and we'll just kind of replace those out a little bit. Remember, you'll notice, guys, I'm getting rid of my magic numbers. Magic numbers are bad, because anytime I want to go and change the change what the life cost is, I only want to do it in one place. Okay. And then we get down to the final one. That's our life cost. All right. I want y'all to notice something. Based on the algorithm, what do you see here?
It's not really doing anything because you can't, like, there's no operator that's being used with spell power. It's just put next to.
Yeah.
So is it multiplying then?
So yeah, we have to change it to a multiplier there. All right, so make sure we change your return values. Okay. Now I've given you quite a bit here, right? You guys can see what the calculate, you can see, excuse me, you can see what the overload methods are, right? So the catch now is how do you write the rest of this code? This is what you have to figure out that will keep going until you run out of the total health. You could say that the object of the game is to kill the player, right? So you want to kind of be creative in how you kill the player. You want to figure out, are you going to call these through how you're going to call these methods through the scanner algorithm? So for example, public double I'm kind of thinking as I go here, okay? So bear with me. All right. How would I do that? Think about the method I just wrote here. How would I do this?
Let's see. But aren't your variables like? You're returning a double here?
Uh-huh.
So I guess it's like if you choose one choices for attack, then you return the double that's assigned to it. But I was like kind of like.
So let's say
I was just gonna store it in an array, like an array of strings, and then like.
could. Let me give you a simple example. So let's say if 1 equals if V equals 1, calculate hit points. Let's make it more interesting. Let's
But it's looking for a hint of something.
yeah, it's
So
math round. It's because random gives us double. So you could do there you go. That's one hacky way to do it, right?
oh, so then that also randomizes the value of hand strike.
Right? You guys get the idea? Do you guys get the idea where we're going with this?
Wait,
Yeah.
So you're, so what was the point of all the constants if the value is determined by the randomizer?
These are just samples.
Oh, gotcha.
Yeah. Right? You could do it any number of ways. You could take your jab and do it as a multiply against a math random, so that you never know exactly what value. It'll be a multiple of whatever that type of hand strike is, but it could be anywhere up that value. Okay? All right, so I've given you a lot of basics here, right? So I would come up here, last thing. I need to call this method. So how am I going to do that? Well, I'll say player health equals new player health, and then player health, choose attack, new scanner system.in. Now, I want you to think about what's still missing here. Is there any user feedback from the calculations?
No.
Yeah, so you guys you'll have to create some type of method that captures the user feedback, right? So you could create a method that says public void user feedback, and now you have something that you could use after the end of each attack. You pass in whatever the total player health is. So for example, right here, calculate user hit points. I could type down here user feedback, encapsulate the whole thing inside that method. Because now I've passed in the value of what's returned from calculate hit points on a hand strike back to user feedback. That make sense?
Mm-hmm.
What else is missing?
I'm just taking away from or like ending whenever the player health is 0.
Yeah. You have to figure out how to kill the player at that point. All right. It is now 5 till 5. We've gone over a little bit. Guys, if you have any questions, please let me know. If you're behind, if you're missing any major pieces of what we've done over the last 6 weeks now, I need you to really be thinking about that, especially the CAs. The CAs are homework assignments. The labs are homework assignments. And the projects are very big parts of the grade. So if you're missing any of those, please come see me so we can make sure that you're staying on top, getting caught up, and staying with us. Cheers. God bless. You all stay healthy. I'll see you next week. Again, if you need to reach out to me, send me an email at any time.